In 1492, Christopher Columbus set sail from Palos de la Frontera in southwest Spain. He headed west in search of a faster route to India, the main route being around the southern tip of Africa. However, Columbus ended up inadvertently arriving in the Americas, likely landing in what is today the Bahamas. He arrived much further south than he left though, as the Bahamas are at 23 degrees north, while Palos de la Frontera is located at 37 degrees north. Had he traveled along the 37th parallel, Columbus would have arrived near the Chesapeake Bay almost 1,000 miles or 1,600 kilometers north of the Bahamas. However, as Europeans were beginning to understand, this trip would have taken much longer due to less favorable weather and ocean conditions than what the more southerly route provides. Earlier, Portuguese explorers sailing south along the African coast realized they couldn't just turn around and head north along the same route back to Portugal because the wind and ocean currents were fighting against them. They worked out that the best route was to head north and west away from Portugal using winds coming from the northeast. As they traveled further north, the wind shifted, now coming from the southwest, allowing the ships to head east towards Portugal. The sailors called this route the Volta do Mar, or return from the sea. What the Portuguese learned is that the winds near the equator in the northern hemisphere usually blow from the northeast, while winds at higher northern hemisphere latitudes mostly come from the southwest. The winds from the east are called the trade winds, while the winds from the west are called the westerlies. Trade winds and westerlies occur in both the northern and southern hemispheres, with the trade winds prevailing from 0 degrees latitude to 30 degrees latitude, and the westerlies being prevalent from 30 degrees latitude to 60 degrees latitude. In the southern hemisphere, however, trade winds blow from the southeast and the westerlies blow from the northwest. The trade winds and westerlies can be shown visually using a wind rose, which shows the dominant wind direction for a given location. In Portland, Maine, located at 43 degrees north, the wind comes from the southwest most of the time, while in Miami at 25 degrees north, the winds blow from the northeast. In the southern hemisphere, the winds gust from the southeast in Rockhampton City, Queensland at 23 degrees south, and from the northwest in Hobart, Tasmania at 43 degrees south. Generally, surface air will move from areas of high pressure to areas of low pressure. Low pressure is common at the equator and polar circles, while high pressure is dominant at the mid-latitudes and the poles. Trade winds and westerlies are created by the Hadley and Ferrel cells respectively. These cells move air in a loop between high and low altitudes. For the Hadley cell, warm air at the equator rises into the upper atmosphere and heads towards the mid-latitudes. As the air cools and encounters high pressure at the mid-latitudes, it sinks back towards the surface and equator, closing the loop and creating the trade winds. For the westerlies, high pressure and downward winds from the Hadley cell force surface winds toward the polar circles, where it encounters low pressure and surface polar winds running toward the equator. These forces cause the air to rise and head back towards the mid-latitudes, creating a loop called the Ferrel cell. The surface winds of the Ferrel cell are the westerlies. If Earth did not rotate on its axis, the trade winds would run from the mid-latitudes to the equator in a straight line, and the westerlies would blow from the mid-latitudes toward the poles in a straight line. However, because of a force called the Coriolis effect, the winds curve. Earth spins from west to east, but at different speeds depending on the latitude. The closer to the equator, the faster the spin, but the closer to the poles, the slower the spin. The effect of this force is that the winds curve from their north or southward paths. In the northern hemisphere, the winds curve to the right, and in the southern hemisphere, they curve to the left. So, the northern westerlies curve right to blow from the southwest to northeast, and the northern trade winds bend right, so they are blowing from the northeast. The southern trade winds curve left to come from the southeast, and finally, the southern westerlies curve along its path to come from the northwest. Another factor influencing navigation is ocean currents. Wind direction is an important cause of ocean currents, along with temperature, Earth's rotation, and salt content. There are numerous ocean currents, but some form a loop called a gyre. Earth's oceans have 5 main gyres, the North and South Atlantic Gyres, the North and South Pacific Gyres, and the Indian Gyre. The North Atlantic Gyre, used by early explorers to reach America and return to Europe, consists of 4 major currents. The Canary Current runs south along the African coast, the North Equatorial Current runs west towards the Caribbean, the Gulf Stream flows north along the North American coast, and the North Atlantic Current flows east back towards Europe. The early explorers like Columbus mostly relied on the winds for their voyages. All of Columbus's return journeys took a more southerly route that involved going against the trade winds for part of the journey and ocean currents for most of the voyage. However, in 1512, Spanish explorer Juan Ponce de Leon became the first European to use the Gulf Stream for the return trip to Europe. The southern part of the Gulf Stream has trade winds from the northeast flowing in opposite direction of the current, but Ponce de Leon observed that the current was stronger than the winds and ships could sail with the current. Further north, the westerlies took over, with both the current and the winds coming from the southwest. Explorers now realized the best round-trip route was basically a clockwise passage. Leave Europe heading southwest to catch the trade winds and use the Canary and North Equatorial currents. Head home using the Gulf Stream, the westerlies, and the North Atlantic Current. It is possible to sail against the wind, but it takes much longer and can't be done directly. In order to head into the wind, a sailing ship must use a method called beating, which involves zigzagging and greatly increasing the total distance traveled. The Mayflower did this when it sailed to Plymouth Colony in 1620. Taking a direct route from England, it sailed head-on into the westerlies and was nearly lost when its main mast cracked during a violent storm. The voyage to North America took over 8 weeks, but the return trip to England, this time sailing with the westerlies, took just 4 weeks. For longer voyages, correctly using the winds and currents was very important. For Europeans sailing to Southeast Asia and Oceania, a distance of thousands of miles, some counterintuitive routes were required. The shortest route to Australia is to sail close to the African coast, around the Cape of Good Hope, and east across the Indian Ocean. However, this route involves sailing directly against the southeast trade winds in the low southern hemisphere latitudes. A new route called the Clipper Route took southbound ships closer to the coast of South America before turning east. They would then sail far south of the African southern tip and use the southern hemisphere westerlies, some of the strongest winds in the world. With very little landmass to obstruct the winds, ships can make great time by sailing at these latitudes, but with strong winds come strong seas. 40 to 70 degrees south are known as the Roaring 40s, Furious 50s, and Screaming 60s. The most dangerous part of the journey was on the way back to Europe, when ships had to navigate the Drake Passage, a narrow body of water between Cape Horn and Antarctica that acted as a funnel for wind and waves. By sailing closer to South America when heading south and along the African coast back to Europe, sailors could take advantage of the South Atlantic Gyre. The journey could take 2 to 4 months each way, depending on the amount of time a ship spent crossing a stretch of calm water known as the doldrums. Officially called the Intertropical Convergence Zone, the doldrums is a narrow band of calm winds where the trade winds from the northern and southern hemispheres meet and rise high into the atmosphere. Ships had to try to cross the doldrums as quickly as possible, as the region has strong thunderstorms, and being stuck for days or weeks could cause supplies to be rapidly depleted. As ships began to use mechanical power instead of wind power, the importance of wind direction and ocean currents was diminished. However, sailing vessels and cargo ships with time-sensitive items can use the winds and currents to get to their destinations as quickly as possible. Sailing vessels racing to circumnavigate the globe still use the southern westerlies, as they are some of the fastest winds on Earth. For weather forecasting, knowledge of the trade winds and westerlies is important for predicting meteorological events like hurricanes. Atlantic hurricanes begin as storms off the coast of Africa and are carried west by the trade winds. If the storm becomes a hurricane and the trade winds are strong, its path will be easier to predict. Additionally, if the hurricane turns north, knowledge of the westerlies is important in determining whether or not they will be able to push the storm back east into the Atlantic. Winds are important in aviation too, as planes using high-altitude air currents as a tailwind can reach their destinations significantly faster. Understanding the global wind system helped revolutionize ocean navigation and made transoceanic voyages possible. Using surface winds correctly allowed navigators to circumnavigate the Earth. Despite many ocean voyages happening on mechanical ships today, wind patterns are still important for weather forecasting, aviation, and much more.